Here is 2.6, day 1, part 2. We're going to next go out and see if there is symmetry in this problem. So here are the rules for symmetry. And for x-axis symmetry, you replace the y with negative y and get the original function back. Then you have x-axis symmetry. And then you continue with y-axis symmetry test and then origin symmetry. So there's my original function. I just replaced that f of x with y notation. And now we're going to test it. If I test the first one for x-axis symmetry, and I replace this with a negative y, do I now have the original function? No. So I know this is a no. I'm just going to erase that negative now. Then we'll test for x-axis, or y-axis symmetry. Replace the x with negative x in the function. Reduce it down. Do we get the original function back?
Yes.
Yes. Then, look back, we just did the replace the x, so now I'll just replace the y. Do we get the original function back? No. So we have one symmetry. That will help us later. So step 7, I kind of wait until after I start graphing this stuff out that I've already found in steps 1 through 6, and then see what additional points I might need. So go ahead and make an xy plane. And let's graph what we have so far. So I just start with the beginning, step 1, and work my way down. So I'll call this 1, 2, 3, negative 1, negative 2, negative 3, 1, 2, 3. Now let's graph the domain restrictions. Those are where x cannot be. So those were your vertical asymptotes. So where were your vertical asymptotes at? 1 and negative 1. So I have a vertical asymptote at x equals 1 and x equals negative 1. Then I had a horizontal asymptote. Where was my horizontal asymptote at?
2.
Minus 2?
No.
Y equals 2? At y equals 2. So then we go up on the y-axis, 2 units, draw a horizontal line, identify that as y equals 2. Then I had some intercepts going on. What was the x-intercept? 0, 0. Where was the y-intercept? 0, 0. And then I knew I had some symmetry. Where is the symmetry at? Along the y-axis. So I know I have symmetry here. Along that. So anything that happens to the right of that vertical line has to also happen on the left. So when I start plugging in points, I don't have to do if I have a positive x, the negative x would be the same value for y, is how symmetry works for this. So that's all I know right now. So now I have to figure out what's kind of happening maybe between those asymptotes and what's happening on the outsides of those asymptotes. So let's evaluate the function. So let's try like 1/2. So let's figure out what's happening just to the right of that x-intercept and y-intercept. So when you evaluate the function, you're substituting in to the original function. So let's let f of 1/2 into the function to find the ordered pair. So I say 2 times 1/2 squared minus 1/2 squared minus 1. And now we have some reducing to do. 1/2 times 1/2 in the numerator is 1/4. Then 1/2 times 1/2 in the denominator is 1/4. Now I'm going to reduce that numerator. 2 times 1/4 is 2/4, or 1/2. And then 1/4 times, or 1/4 minus 1 is negative 3/4. So I have a fraction dividing a fraction. So I can change that to 1/2, change that division to multiplication, and reciprocate that denominator as negative 4/3. Now I can multiply across as negative 4/6 or negative 2/3. So if I go up to my XY chart, I evaluated it for 1/2, so I got negative 2/3. Now there's symmetry with the y-axis, so if I plug in negative 1/2, what would I get?
2/3.
Negative 2/3 also. So I save myself a little bit of time and not have to evaluate again. So let's graph those 2 points. So I have 1/2 down negative 2/3, so about negative 0.6 here, negative 0.6 here. What do you think is going to happen as we move a little bit to the right of 1/2? It's like 3/4. What do you think is going to happen here? It's just going to kind of come down and approach those vertical asymptotes. So we have kind of like a little mini parabola going on between those asymptotes. Then I know some things about, those were the most amount of x-intercepts I could have. So now I have 2 more sides to still kind of check into. Something maybe to the left or the right of those other vertical asymptotes. So I'd evaluate the function again. So choose a nice number like 2. We'd evaluate the function for 2. It's going to be below the x-axis or above the x-axis. It can't be on it. So we evaluate again. Change colors here. Pull this down. Okay. So we'll say f of 2. 2 times 2 squared over 2 squared minus 1. 2 times 4. 4 minus 1 is 8/3. Which is about how much as a decimal? So the ordered pair then is 2, 2.6. So 2 and then approximately 2.6. Do we not know another ordered pair now? Due to symmetry? Yep. Negative 2, we'd also have 2.6. So now let's graph those ordered pairs. Over 2, up 2.6, left 2, up 2.6. what do you think is going to happen at this green dot? I think it's going to happen in that, like, area, in this area right here, with those asymptotes. Probably a curve. So we were saving ourselves a lot of time. Maybe you want to try one more point. But those asymptotes help guide the curve. Now there's symmetry. So what would happen over here then? Same thing. And there is our beautiful looking rational function.
So is there going to be like more than one picture?
More than one picture?
Like, yeah,
Like part of your notes?
parabola thing,
Yeah, that whole thing is your entire rational function. All those pieces. The mini parabola and the two curves make up the entire picture of the graph. Yep. We're going to do one more example, and I'm going to give you a hint. This one's going to have the slant asymptote. And we don't do these in Algebra 2, so you're going to really want to pay attention when we get to the slant piece.